The rate of a particular reaction is defined in terms of the rate of change of the number of moles of reactant A. At the start of the experiment, there are 0.4. After 25 minutes, there's 0.1. The average rate of change, the rate of the reaction in this 25-minute period is, and we need it in moles per minute. So change in concentration divided by the change in time would be the average rate for us. We start with 0.4, we end with 0.1, so that would be 0.3 over that period of time. And the period of time is 25 minus 0, or 25 minutes. 0.3 divided by 25 ends up being 0.012, which is letter B. 1.5, similar question. This one now has 0.1, and it goes to 0.05 in 25 minutes. 0.1 minus 0.05, that means we are going to have 0.05 remaining. The amount of time, once again, is 25 minutes. So divide those two, we end up with 0.002 moles per minute, which is B. Number 2, 0.1 mole of each reaction is initially present. The rate of reaction with respect is negative 0.1 mole per minute, negative 0.1 mole per minute, negative because A is disappearing. Assuming a constant rate of disappearance, which is close to the number of moles of B remaining after 5 minutes, you'll notice A relates to B in a 1-to-1 ratio. So we can say that we start with 1 mole. We're going to subtract from that the amount that goes away in 5 minutes. And in 5 minutes, there are 0.1 moles that disappear per 1 minute. So the minutes cancel with the minutes, and this will tell us how much will disappear. This part right here ends up being 0.5 moles. 1 minus 0.5 means that there are 0.5 moles remaining, and that is letter C. I'm sorry, letter D. 2.5, similar question. This time we start with 10. And this time there are 2 minutes that go by, and there are 0.5 moles that disappear per every 1 minute, negative because of course it's disappearing. 2 times 0.5 is, of course, 1. 10 minus 1 is 9. So there will be 9 moles remaining, which is number B. The rate law for the reaction is first order in A, second order in B, then the rate law is, so first order in A would be a 1. For B, it would be second order. We'd put the K. Rate equals A to the first, B to the second, which is letter C. Rate law is third order in A, so A would have a third power. Second order in B, so B would be second order. Put a K in there. Set it equal to the rate. A3, B2 is letter D. More on the next.